Let's do an example of an oscillating spring. So this is problem 29 from your book. I have a spring that's hanging from a ceiling. It has a certain mass on the end of it. We'll call that m naught. And it oscillates with a frequency f naught, certain number of hertz. And the question is, what happens, well, first of all, what is f naught related to, and what happens if I increase this from m to 9m? Okay. So we want to see what happens if I increase the mass of this and see how it responds. Okay, so my solution for this, I'm going to write down my angular frequency, so k over m, and I know what m naught is. Now I don't know what omega is, but I'm interested in the frequency. I do have at least a variable for this, so let's go ahead and put that in there. I know that omega is equal to 2 pi times the frequency, so my omega naught is 2 pi times the frequency. So I'm just going to go ahead and say that 2 pi f is equal to the square root of k over m, and then I can say that my f naught is equal to 1 over 2 pi times the square root of k over m. Okay, so now the question is, I don't know what k is, but I'm just asking the question, what happens if I make m naught go to 9m naught? So I don't really care about any of this other stuff because I'm just trying to do a comparison. So I'm going to go ahead and make a ratio here. I'm going to say the frequency at the initial mass divided by the frequency when it's 9 times greater is equal to 1 over 2 pi times the square root of k over m naught, and that whole thing is divided by 1 over 2 pi times the square root of k over 9 times m naught. And now you'll notice that all of these things cancel out. My m naught even cancels out, and I wind up getting a factor of the square root of 9 on that side because that's in the denominator down there. So what that's telling me is that the initial frequency is square root of 9 times greater than the final frequency. And so I can just write that down as that. Or if I put this in terms of the final frequency in terms of the initial frequency, I get that it's 1/3 less. And so what that tells me is the frequency with more mass is slower, which is what we expect. So my significance is that I get a smaller frequency, which is what we expect, and I notice that because this scales like the inverse square root of the mass, I wind up, if I increase the mass by 3, I wind up with a decrease. Or if I increase the mass by 9, I wind up with a decrease of 1/3. And that makes sense.